I'd like to welcome everyone today to our webinar. My name is Andrew Kling. I'm with the University of Maryland Extension Woodland Stewardship Education Program at the Western Maryland Research and Education Center. We're located in Keedysville, Maryland, in the western part of the state. If you're familiar with the geography of Maryland, we're about 10 minutes south of the city of Hagerstown. Today we're going to hear from my colleague Lyle Almond on the subject of nature-based forestry, the pro-Silva movement in Europe. But before we get started, we've got a few housekeeping notes to go over. If this is your first time with us, we're glad you're here, and if you've been with us for other webinars, we're happy to have you back. A few things we need to talk about before we get started. If you're interested in our webinars as a whole, we do these on a periodic basis. We try to do them quarterly, but the easiest way to stay in touch with us to find out when our webinars are being held and the topics is to join our email notification list. Send an email to listserv@listserv.umd.edu, or you can drop me a line directly at akling1, that's akling1, at umd.edu, and I'll make sure that you get onto the list. When we hold these webinars, usually the first 100 people who log on get to attend that particular day, and that's more of a bandwidth issue more than anything else. And if you discover that you can't be with us for the entire hour, or after we've gone through the webinar you realize, hey, this is something I want to share with someone else, we do record all of these webinars and post them on our YouTube channel so we can share that with everyone. Go to youtube.com/c/UMDFSE. And for those of you who registered for the webinar through Eventbrite, once the recording is taken care of and posted on YouTube, I'll send out an email through Eventbrite with the direct link, and you can find out how to watch the webinar at your leisure. We also advertise the webinars on our website at extension.umd.edu/woodland and on our Facebook page, so you can find out what's going on with the Woodland Stewardship Education Program there as well. And as we go through the hour, if you have any questions, the easiest way to get a hold of us, get our attention, is to type them in the chat box. It'll stay there in the lower left-hand corner throughout the hour. Many times we get a chance to work on the questions during the program, but sometimes we don't. We get moving on to a different part of the presentation, and we will go back through the chat box to make sure that we've caught everyone's questions. Occasionally we run out of time at the end of the hour and we don't get everyone's question, but we'll make sure that we get the information to you. And occasionally we get folks who come up with a question after the presentation's over, or once they've seen the recording. Easiest way to get a hold of us is, once again, through a direct email to me at akling1@umd.edu. Now, before I turn things over to Lyle, we have a few poll questions to go over. Just 5 questions real quick. They're all mostly demographics at this point, and we'll have a few more at the end as well. So what I need you to do is to go ahead and click on the radio buttons for what makes the most sense for you. Firstly, I'm interested in this topic as a landowner, forester, etc. And you can see the results right there as people put in their information. Secondly, we'll ask you to tell us how many acres of land you own, and then what region do you live in. We had people register for this through Eventbrite from at least one participant from Canada who registered, and we had folks as far away as Wisconsin and Nebraska. So we always like to find out where people are as we do these. So I'll just give them a minute or so to make sure that the numbers aren't moving anymore. See that everyone has given us some feedback, and then we will move on. Okay, I'll go ahead and close the first poll. And it looks like the second one has finished as well, and the same with the third. Okay. Thank you very much. And we got 2 more quick questions for you, please. If you were going to travel to your county extension office to participate in this webinar, how far would you have to go? Some folks may not know where their local county extension office is. That's something you need to know. Every U.S. state has a land-grant university with extension programs, so that's something you may want to look into, because there's all sorts of great information. And then on a scale of 1 to 5, what's your knowledge of continuous cover forestry before we get started with all of this? Okay, looks like we've gotten feedback on just about all of these. I'll go ahead and close that out and close out the second one. And let me bring up Lyle's photograph and get his slides ready. And while that's loading, let me tell you a little bit about him. Lyle Almond is the Forest Stewardship Educator for the University of Maryland Extension at the Y Research and Education Center. So he's on the eastern shore. He's at the other end of the state from me. He spent 10 years as a forester on the Olympic Peninsula of western Washington. After receiving his master's in Forest Resources Management at the University of Washington, he worked for the Washington DNR as a regeneration silviculturalist and as both a forester and restoration ecologist for the Makah tribe on Washington's northwest coast. He recently completed a Fulbright exchange in Slovenia, where he studied the European tradition of nature-based forestry. And that leads us into his presentation. So, Lyle, if you're ready to go, we'll go ahead and turn things over to you and take it away.
Segue into my presentation. And I'm actually going to dip a little bit into some of the science, some of the history. So for some of the number of the foresters out there, some of this may touch on some familiar areas for you, rather than to present a travelogue of my adventures in Europe. After presenting my graduate thesis at University of Washington on stratified mixtures of Sitka spruce and red alder and their success in mitigating spruce weevil damage, I felt there was a lot more I needed to know about the dynamics and management of mixed species forests. If they're so much more resilient than pure stands in facilitating integrated pest management, then what other advantages could they provide? And why are forest mixtures so much better able to outperform their single species counterparts in biomass productivity? These kinds of questions led me on a 7-year quest that took me down several roads, including a quantitative understanding of niche complementarity, which is the dynamic behind ecological combining ability, by which species mixtures that are best able to share or partition a limiting resource like sunlight often tend to overyield or yield higher rates of biomass production than pure stands at equal stand densities, and how we might optimize a more full range spectrum of light use efficiency using silviculture in multi-layered forest mixtures by modeling variations in the utilization of solar radiation by foliage along a vertical light gradient in the forest canopy. I stumbled by chance when I was looking at this on forestry in Wales, and discovered that there was an innovative program in low-impact silviculture by the Forestry Commission, as well as a very active group of foresters known as the Continuous Cover Forestry Group. This gave me an opportunity to travel to Wales, Scotland, and Ireland to meet with several proponents of this continuous cover forestry system and look at the silvicultural practices they were advocating. I'm sure you can see here a number of examples of some of the regeneration that seems to be popping up everywhere in the understory in what were predominantly Sitka spruce forests. In Britain, forestry, as we know it, probably didn't really come to bear until about 1919, when the Forestry Commission was established. And forestry in Britain and in Ireland as well has been built primarily on the success of Sitka spruce, which is one of our native North American trees from the Pacific Northwest. And in fact, most of the commercial tree species, if not all but one, I think, Scots pine being the exception, are exotic tree species. So as they continue to build this program of forestry on the British Isles, they've moved from about less than 9% to roughly 15% canopy closure or forest cover across Britain, and this presents a number of other issues as well that are largely social. However, I discovered on making several trips back there that I was amazed at really at how well the concepts in forest management that I'd been studying on an experimental basis were being put into professional practice. So I made numerous trips back to Britain, and I learned that this continuous cover forestry group is actually one chapter of a much larger pan-European network of foresters known as ProSilva, or the ProSilva Federation. I expanded my network to other parts of Europe, not just Ireland, Scotland, and Wales, but into Denmark and northern Germany, a little bit of southern Sweden, Switzerland, and eventually into Slovenia. And I think if I move the arrow here, you can see the little tiny country of Slovenia over here next to Italy. To give you a better idea of where it's located. And actually, Slovenia, for its size, is the third most forested country in Europe after Finland and Sweden, and is actually considered the ancestral cradle for this nature-based continuous cover forestry method. It seems to have originated there in the Alpine foothills by villages and farms that were actually trying to manage for protection against avalanches by maintaining a forest that was resilient enough to protect them, of course, from damage by rockfall, snow avalanches, etc. In 2010, I was invited to speak at an IUFRO conference on uneven age silviculture in Ljubljana, which is the capital city of Slovenia, where the National School of Forestry is located. There I was able to meet foresters from all over Europe who are part of this pro-silva movement, as well as a number of American foresters who also specialize in mixed species silviculture. And a year later, I received a scholarship from the Fulbright Commission to spend a year in Slovenia studying this ancestral practice of nature-based forestry that originated in the alpine forests of Central Europe. It was also here that I learned about the innovative work of Dušan Milinček, who is Slovenia's great patriarch of modern nature-based forestry, that he had developed the Sproščena tehnika, which I may get into later on. So let's step back a little bit and let me explain what continuous cover forestry is, what I mean by nature-based forestry, a little more about the ProSilva Federation. Nature-based forestry, continuous cover forestry, the Planterwald, La Fute Jardine, which literally means the garden forest, close to nature, Sproščena tehnika, La méthode du contrôle, etc. This system has as many names as there are languages spoken in Europe. But and also there's an issue of the traditionally having developed various systems of management on a very regional basis, from one forested valley to the next over the course of generations, which led to notably different management systems. But I think that the universal acceptance has been to refer to it as nature-based forestry. This was the term that my professor at University of Ljubljana, Juri Diaci, used for his comprehensive compilation on the subject, which is titled Nature-Based Forestry in Central Europe, which you can download from the ProSilva website at this address on your screen. Also on that website, you will be able to download what I call the Little Green Book, which is the ProSilva Federation's guidelines or its manual, and look at what the overarching principles of continuous cover or ProSilva or nature-based forestry are. And the first overarching theme is to adapt the forest to the site by working within the site's limitations and respecting ecological processes, inherent variations, instead of trying to impose this artificial uniformity across the landscape. Also to use and to rely on natural regeneration instead of artificial regeneration, and focus primarily on developing mixed species and mixed age stands. One of probably the first precepts of pro-silva forestry is to protect the soil above all else, and this is what from that leads to the practices of continuous cover forestry, soil being, of course, the most important non-renewable resource. So in doing this, foresters were attempting to adopt a more holistic approach. They look at the forest ecosystem as the production capital of the forest, which of course includes the soil, microclimate, and associated flora and fauna. In setting allowable harvest levels, continuous cover forestry looks at this production capital as a baseline, an asset, and the periodic increment that accrues over time is that interest that grows, into which harvesting can take place, and only some part of that interest. When I was in Slovenia, the directive from the Slovenian government was for the Slovenian Forest Service to increase its harvest levels from 2% to as much as 8% of this increment. So the management is directed towards creating, maintaining, and enhancing a functioning ecosystem rather than this periodic creation and removal of individual crops of trees. Well, out of these guiding principles, three things become clear. One is this emphasis on vertical and horizontal structure. The use of the overstory canopy becomes a critical tool to influence the amount of light that reaches the forest floor. That is the tool for management. Also to limit undesirable invasives, trigger regeneration, and then control its development. And the emphasis is on developing a diverse array of species mixtures in a range of mixed age classes. So if clear cutting takes place, these forest functions are lost and the benefits of that shelter are reduced and natural regeneration becomes more difficult. Where nature-based forestry is practiced, concentration is on developing preferred individuals, or what are known as frame trees, throughout the stand that possess characteristics that the forester wishes to preserve for as long as possible, and to bestow on the regeneration that will then come from those individuals, and to build the forest around those frame trees rather than creating a block of stems with uniform spacing that have these average stem characteristics. So this management of individual trees or groups of trees takes place within the context of the entire forest, so that the size and composition can be manipulated to achieve desired rates of regeneration. And it's regeneration that is the highest objective in close to nature forestry in order to produce a number of different forest outputs. So the paradigm changes a little bit because yield control of these stands is based on the range, the measurement and range of the stem diameter distribution and their increment, rather than focusing on the area of a stand, a harvest area, and the age of the average age of the trees. So again, the emphasis is on vertical and horizontal structure. It emphasizes developing a diverse array of species mixtures and a range of mixed age classes. And so selective tree silviculture becomes the primary management tool for them. And this is a general term as far as nature-based forestry is concerned. It's a general term that covers several silvicultural systems which conserve the forest structural canopy environment during the regeneration phase. General aim of all the systems within nature-based forestry is to encourage this diversity of structure and uneven age size on an intimate scale. That means as closely as possible with the intimate mixing of species and the mixing of size classes. The classical silvicultural system to create these conditions, of course, is our single tree selection system, which we're familiar with, and group selection systems as well, which generally involve openings in the canopy that are less than, well, maybe a little more than half an acre. And, you know, as much as I speak about ProSilva as a movement, and I've also referred to it as an actual federation or an organization network, it's also, and also I refer to it as an ancestral practice that goes way back to the pre-industrial farms and villages of the Slovenian Alps. It's also an institutionalized practice that is practiced. It's enacted within the forestry codes of most, if not all, of certainly in continental European forest agencies. For example, in Germany, the individual states of more decentralized government all have regulations regarding the maximum size of openings, none of which are larger than 3 hectares that are allowable. There's a third system in addition to single tree and group selection, which is the irregular shelterwood system, which we may be a little more unfamiliar with, where the overstory shelter is retained longer than 10 years. This, of course, is not a selection system, but a regeneration system, in that at some point all of the canopy will be removed. And we can look at this, if you can see this diagram, and look at the different stages of removal, where the original stand has had several openings created in order to produce these, what I refer to as cones of regeneration, to occur in these smaller openings. And then over time, of course, given the monitoring and subsequent follow-up management that needs to be made to ensure that those openings are regenerating properly, those circles are opened up more and more until eventually we have these huge waves of regeneration, representing another uneven aged stand. And also, this will come up a little bit later too, but notice these openings here, which have R for road. These roads are generally placed as part of what are known, and this goes on all through Europe, in stand compartments that have roads or tracks that that feed into the main haul routes that are permanently maintained, rather than having machinery moving into the harvest unit, exposing, disturbing soil. These tracks, which are generally straight roads that come from the main haul road, I'm thinking about 150 feet apart or more, represent a way for them to gain access to all parts of the stand by using equipment that can reach in and remove trees and yard them back to the main haul route. And here's another depiction of that. As you look left to right, you can see the incremental stages of this irregular shelterwood moving from here. Smaller openings are created, and those openings are enlarged until finally you have this non-uniform stand of trees that are a number of different size classes. And again, notice these tracks that are regularly placed pretty much consistently at about 150 feet apart. This reverse J-curve distribution of stems, Francois de Leaucourt in 1898 first described this this shape, this reverse J shape, in managed uneven stands of fir forests in France. This slope, this is another way of looking at it when you compare it to the way an even-age stand looks with this unimodal axis versus the reverse J of the uneven age stand. The shape is defined by the diminution quotient, Q, which expresses the ratio of the number of trees in any diameter class to the number of trees in the next higher diameter class. Usually the Q value ranges from 1.3 to 2.0 for each 2-inch diameter class. So low values of Q will result in a flatter curve, which produces a stand that has with a higher proportion of growing space devoted to larger trees. And stands managed with higher values of Qs have more trees in the smaller size classes. So stocking and stand structure can be manipulated by altering the value of this Q value and the maximum diameter that's desired in order to meet management objectives. If we want to look at this closer, we can look at the stand attributes of different Q values by looking at the number of trees per acre and the basal area for each of these two examples within each 2-inch diameter class, where the maximum diameter of 24 inches is for two different Q values. For here we have one where there are 2 trees per acre that have a maximum diameter of 24 inches and a Q value of 1.3, and another example where there are 0.5 trees per acre with a maximum diameter of 24 inches and a Q value of 1.8. Now in example A, more growing space is allocated to the trees of the larger diameter, and basal area is at 71 square feet per acre, which is below full stocking. Generally, stocking in uneven age stands is maintained below full stocking in order to allow space for further growth through this through this range of diameter distributions and the progression of trees into the larger size classes. In example B, most of the basal area is in the smaller size classes. And the basal area of 114 square feet per acre is at or above full stocking. With this diameter distribution, the space is not available for further growth, and cutting is required to allow more growing space so trees can remain vigorous and progress into those larger size classes. Here we can see examples of 4 stand structures in vertical cross-section with corresponding graphs of diameter distribution. We have what we've been talking about, the balanced uneven age stand with that reverse J curve, as compared to an even age stand with this unimodal curve of an average stem size. We also have the stratified even age stands like the ones that I was doing my research on in grad school, which are all the same age but comprised of very different species that stratify into different parts of the canopy, also with that reverse J curve. And then what are referred to as irregular stands. They're uneven aged. They're quite irregular, but not balanced. And you can see that there are 3 size classes here. This balanced uneven age structure resembles the stratified even age structure, even though the number of age classes is decidedly different. However, structurally complex stands usually require maintaining trees of different size classes in the same area, frequent periodic harvests that are more or less equal in time, and usually on cutting cycles that are maybe between 5 and 7 years, as opposed to an even age system where harvest entry might be made once every 40 to 60 years. and ensuring that trees are removed on an individual basis to leave a desired number of trees in each size class. In other words, this suggests the use of proportional thinning. The term that I started picking up on in French was pied à pied, which my little knowledge of French led me to translate as foot by foot, which of course makes no sense. Until I was in the Couvet forest with a well-known forester named Jean-Philippe Schutz, and could look and actually see it in a way that would be difficult to describe without being there. But it was quite clear that in that forest, each tree seemed to have been not only chosen, but managed for its position in the canopy. And there seemed to be much more care as far as structuring the forest. But another guiding principle is to ensure that each harvest stimulates reproduction and enhances the growth of the remaining trees. This negative exponential distribution is based on a balanced size class forest structure characterized by that reverse J-shaped curve. However, as you can see here, balanced uneven age stands are a human construct that generally do not occur in nature. And the Q value is an arbitrary diameter distribution to demonstrate how stocking control can be influenced. Despite criticisms about the relevance of the balanced equilibrium forest as depicted by this reverse J, it'd probably be better if we understood that these deviations that you see here are really the result of observations that are made in natural unmanaged forests or possibly managed under some system other than the Plenter selection system, which is the German phrase for the continuous cover forest. The equilibrium condition might be thought of as a goal to be achieved by the decisions we make, not simply as a model for looking at existing stand conditions. A classic example of this deviation can be found in the rotated sigmoid curve you see here in the curve stem and the stem distribution. This term mesophication refers to the encroaching dominance of shade-tolerant codominant trees in the canopy layer, which is something we experience quite often here in North America, particularly in our northern hardwood forests, where shade-tolerant trees like maple, ash, and so on, which are better able to grow in the shade of shade-intolerant overstory trees like oaks and hickories, become established. And once they do, they prevent the establishment of shade-intolerant trees in the understory. This condition certainly justifies a decision to use proportional thinning in order to open more growing space for those less shade-tolerant trees that are in the understory and the regeneration, and then be able to restore the curve of the reverse shade distribution. Another thing that I came across by a way of looking at this was looking at this thing called the variable G cum, the cumulative basal area or density index from trees that are larger than a given tree, which depicts differences in the stand canopy closure that are experienced by trees in each diameter class. So this crown projection model shows G cum is defined for the lowest diameter as the sum of the cross section, and by that we mean the basal area, not this cross section. But the cone is a 60-degree cone opening, showing how much and to what degree a given tree at its mid-crown position or mid-crown area of its largest crown width is subtended by the crown of a neighboring tree, to show something of a competition index in the vertical structuring of the forest. So anyway, let's step back from that. One of the things that fascinated me also about this nature-based method of forest management also carries social implications, like niche complementarity. This concept of niche complementarity, by which species share limiting resources rather than trying to outcompete one another, is analogous to social value allocation theories that advance the triple bottom line in sustainable management. For instance, these are ideas that are based on game theory concepts like the Pareto optimality and the Nash equilibrium, which advocate solutions simultaneously addressing economic, social, and ecological parity by advancing common social interests to the edge of this opportunity curve, which is what is referred to as the Pareto frontier. So if we were in a negotiable situation where there are different parties that represented different interests, we would want to work toward a solution somewhere here rather than here or here in point A or point H, and hopefully go beyond point K and get as far out onto that frontier as possible so that all constituent parties could maximize or at best optimize their interests in this in the context of this situation. The plant biologist John Harper said it best. John Harper studied and discovered a lot of the ideas that we use today in mixed species forestry. When he commented that species complementarity is like an existential game in which the object is not to win the game, but to continue playing the game. And we see this played out in mixed species uneven age forests where coexistence optimality can be achieved within a limiting resource, such as sunlight, when it's partitioned by trees that are able to grow in different portions of the canopy. But we also see it in management decisions that are made within the 3 dimensions defining multifunctional silviculture. All 3 of these dimensions need to be considered simultaneously, as these 3 dimensions don't necessarily converge. Absolute naturalness is neither convergent with structure nor with the decisions that are made around silvicultural, the cost of silvicultural intervention. So a realistic and opportunistic polyvalent silviculture we have to seek optimal ways for realizing the best combination of these 3 axes. Another idea surrounding this, of course, is the guiding principle of biomimicry. The European forestry practices that were designed to achieve these multifunctional objectives, that they constitute this deep-rooted tradition of biomimicry, which is optimizing nature's best ideas and adapting them for human use. Stand interventions that emulate the natural formation of canopy gap openings represent opportunities and strategies of biomimicry in forest tending under nature-based management by employing natural rules of self-assembly, such as the regulation of overstory canopy shade as a tool for managing forest development in the understory. As it's been practiced and refined in Central Europe over hundreds of years, this silvicultural legacy has produced many of the world's most enduring, most lucrative, and most beautiful forests. So we can see a cross-section here of the single tree selection forest to look at this uneven aged, balanced condition. The other practice of group selection forest, we can look at this and see how it's been carried through subsequent entries, again on this 5 to 7 to 10 year cycle. And we can also look at the irregular shelterwood system as the third of these 3 primary management systems that are often used in European forestry. In this case, known mostly as the Femmelschlag. There are a number of others. This is probably the one that's most familiar to people as stems are removed, first of all, to select their frame trees, and then to create these openings that eventually create those cones of regeneration and result in these uneven stand structures. So The Pro-Silva network has established and recognizes a number of what they refer to as exemplary forests. In Slovenia, the Pahernik family forest in the Pohorje Mountains over towards Hungary, a few others here in Germany, and in Switzerland there's the Couvet forest, for example. Let's see if we can take a look at some of that. The Couvet forest in Switzerland is one of the sort of, I guess you might say, shrines of continuous cover forestry. This forest has been managed without interruption since the 1800s using this splinter system of selection forestry. It was initiated by Henri Biolley using what he referred to as the control sampling methods. One of the best examples of splinter system forestry in their first spruce beech mixed forest at the mountain level. His methods were developed in this forest in the Swiss Jura region based on this vision that silvicultural treatment could be driven by optimizing the forest stand's regeneration, nurturing, and selective objectives based on a range of different growth patterns by these individual frame trees. This is what liberated forestry from a predetermined stand renewal model based on rotation age. Again, we were looking at the Pahernik forest over in Slovenia. This is where Dusan Milinček in the 1960s developed his idea of the Technika Prošena by carrying out gradual transformations of Norway spruce plantations into more natural structures, and using this control method. And a little history that prior to the 1940s, when Slovenia was still part of the communist regime of Yugoslavia, some of these structures were already preserved due to the selection management that had taken place prior to the communist occupation. But in 1949, the Yugoslav government prohibited all clear cutting by law. And in 1952, they began to carry out very specific 10-year interval forest management plans and more detailed plans in 1957. So this irregular shelterwood system was initiated, and Milinček began to look at the confinement of using one or more of these systems in their compartments and developed this typically Slavic idea of making decisions based on what was in the heart of the forester, as it was put to me, rather than looking at so much at the science regarding more the art of silviculture, and came up with this freestyle system in which you might see various irregular shelterwood openings in which there may be some single tree selection surrounded by some group selection openings as well. And this was all regulated and orchestrated by a forester that was, from what I was repeatedly told, was carried out as more of a creative, heartfelt response by the forester rather than scientific analysis. And before I'm done, I also wanted to mention another development going back to the 1920s by Alfred Muller, a German forester, who came upon an estate forest of Scots pines that were a pure stand of trees that were being managed as a perpetual forest, or what was he referred to as Dauerwald. And this refers to a set of principles that, again, as you go down the list, you see avoid clear cutting, every tree that is growing is retained, while those that are ceased growing vigorously are removed. Of course, the concepts of rotation age class are abandoned. Interestingly, regeneration becomes a secondary consideration here, and it's not the main driver of the system. And the elaborate calculations for fixing the annual yield are abandoned in favor of determining the increment, the periodic increment measurement as a means to regulate stocking levels. It should also be noted that this became a favored system of silviculture by the Third Reich, and that this became associated with Nazism over time, and that it was actually after that the fall of the Third Reich that the Swiss foresters in particular revolted against this imposing of a Dauerwald system in their forests, and it eventually would have gone to Slovenia, to Malinchek, to devise this means by which foresters were able to open up their practice in a way to take much more full advantage of all the different systems of management that are available on a site-by-site basis. So finally, I just wanted to mention that there is some innovative training that began in France called the Marteloscope, and it was actually imported over into Britain as a means to train foresters to make these kinds of decisions in the woods. It's a 1 hectare permanent plot in the forest in which every tree has been measured beforehand, and then foresters are generally set loose there to make decisions about which trees should be cut. And then those tally sheets are then tabulated into some kind of software program to look and see, you know, are future stand characteristics and other certain stand values going to be ensured by those decisions. I was in a Marteloscope training, and I have to say I was in a team of 2 people that were the probably the most aggressive as far as the removal of the trees, and it was an interesting exercise to be able to get a much clearer picture on the ground of how to make silvicultural decisions using this nature-based forestry method. So that's my talk, and I hope we have some time for questions.
Yeah, Lyle, we do. We do have a little bit of time yet. Donna has a question saying, I'm assuming that Europe does not have a deer problem like we have in the mid-Atlantic states, in her case, Pennsylvania, so that regeneration in Europe is more natural and cost-effective. In other words, they don't have to fence out deer and use tree tubes and so on. Is that the case?
High-level talks between the forestry establishment and the wildlife biologists about what to do about the deer. And my observations in the public forests in Slovenia, and especially and particularly even around exclosures, was the paucity of regeneration in some cases. So definitely, I think you know, this grew out of, you know, historically out of a strong tradition of hunting. So I think that the two kind of go hand in hand. In Germany, that seems to have been maintained culturally as an idea, and what it would really be considered a more like multi-use function for the forest. In Britain, where the move is more towards going away from the exotic conifers to what they refer to as their native broadleaves. They do use a lot of tree tubing, and entire like fields of because they're establishing new forests, and they all have deer problems.
A couple of other questions. Stephanie was wondering if you could adapt such management for deer in a cost-effective manner. You were talking a little bit about that. But then Jen is asking, if a forest has been high-graded, do you have any suggestions on how to move forward into this type of management?
A survey of the existing forest structure and decisions made about which, first of all, what is the desired size of the largest trees, and what the distribution of stem sizes should be, and to compare that with where you're at now. That would definitely lead you to some decisions about either restocking or changing some of the stocking over toward the larger trees in order to provide future seed source for regeneration. Of course, this issue kind of necessitates whether or not to supplement natural regeneration with artificial regeneration. Another question is, with having been high graded, the larger trees in the stand may actually be the less desirable trees, and therefore decisions about whether to use those as seed source for natural regeneration may be an issue, but more importantly, how long to leave those trees in the stand and for what purpose becomes another question. In some respects, once the stand is high graded, some might say you must have nothing to work with, and so you, in a sense, almost begin again in some way with the existing stand as something of a residual record of the species and growth rates that were that one could expect.
Okay, two other questions right now. I can answer one of them. Crystal wants to know, will the slides be available after the webinar ends? Generally, what we do with the webinar is we post the recording, we put that on YouTube, we put a link to the recording on our website, and we usually post a PDF of the slides as well. So I'll get with Lyle to make sure that we have that available as well. And then Chris wants to know, how economical is this system compared to even-age management or to traditional shelterwood management?
Flow of timber revenue over time because of the repeated and frequent entries that are made into the forest in order to extract commercial timber. As opposed to this one-time or maybe two-time only entry, we certainly in North America and in Europe as well, might employ commercial thinning. In fact, you might consider some of these systems to be a more intricate form of some kind of commercial thinning process. In addition, you refer to the shelterwood system, which of course in our uniform system only gives us a window of 10 to maybe 20 years, I'm thinking, of 3 cuts before the stand is regenerated, before it's no longer commercially available for harvest for perhaps 50 to 60 years. Whereas in these irregular stands, they're balanced equilibrium stands that are in Europe, they've been drawing off timber from them perpetually since they started taking records, over 100 plus years ago, maybe 200 years in some cases. So that more even flow of timber produces a much more stable source of revenue, one that allows you to probably get around the likelihood of some kind of maybe large disturbance to the stand that might take place in a 50-year increment versus a 10-year increment. And I certainly think that as you keep working that stand on a more regular basis, that you will be able to not only maintain its vitality better, but also eventually find certain trees there that over time can be cultivated as what they refer to as noble trees. By that they mean certainly they're oaks, but also black cherry, black walnut, and several others that are highly valuable on the market. and can be grown to such large sizes that they're actually sent off to auction.
Okay, we've got 2 more questions, but what I'd like to do, since we're getting up towards the end of the hour, Wendy and Nancy will get to your questions in just a minute. Lyle will hang on. Before everyone takes off, let me grab some feedback from you, these final poll questions, if you would, please. And real quick, go ahead and put your information in there, and we'll move on with the next thing. And the 2 last questions we have for you, Lyle. Wendy wants to know, are there any examples of this type of forestry management here in the U.S. and especially in Maryland?
Examples as well is the Clinch Valley project in Southwest Virginia, which is managed by the Nature Conservancy. Greg Mead is their forester, and he has been implementing uneven age silviculture on a grand scale, so to speak, if you will, among a group of landowners in that part of the state, in the Clinch Valley. And that's part of a much larger issue, economically speaking, where these landowners have agreed to be formed into a forest bank, so that revenue not only will become over time more evenly distributed over time, but more possibly evenly distributed among the landowners as well, as a collective, so to speak. There are certainly many other examples, but that's the first one that comes to mind. In Maryland, I'm not as familiar with that. I could make some projections about what would be nice in terms of working with things like pure loblolly pine and so on that we might be able to do, but it would be good to see that. Clinch Valley, C-L-I-N-C-H, Clinch Valley. You may have to make a phone call or 2, and if you can or need to, you can actually get on the phone with Greg Mead and talk to him. They've actually, I wouldn't say published, they've printed a very nice hardbound volume of their management guidelines, if you'd like to see about those. I'm not sure. Those actually might be online now.
Okay. And finally, Nancy wants to know if you had any opportunities to view stands infected with disease or pests, and were those stands managed any differently? Nancy was wondering if you had an opportunity to view any stands during your time in Europe that were infected with diseases or pests, and were they managed
that were, that would have made their way through the,
I can
conversation wherever I was. I just never really heard about that. I mean, and although yes, I mean in Britain, for instance, there are several insect pests, but and fungal pests as well. They have Phytophthora on their Japanese larches. And the fact is, though, that in Britain, almost all the trees that are managed commercially are exotics.
All right. Okay. So I believe we're just a little past 1. So I want to thank everyone for joining us today, and Lyle, thanks for giving us all this great information. Once again, we will be recording. We've been recording this, and it'll be available on our YouTube channel probably next week. For more events and more webinars, we invite you to go to our website at extension.umd.edu/woodland. And if you had registered for the webinar through Eventbrite, we'll be sending out an email once the webinar is posted on YouTube. And if you haven't registered, if you didn't have a chance to do that and you've participated today, go to our website and we'll have the information there with the link to the webinar's recording and to the slides as well. So once again, for Lyle Almond, this is Andrew Kling with the University of Maryland Extension, thanking you for joining us today, and have a great rest of the day. Thanks again.